Welcome to my demonstration of OmegaRace, the game that was originally multiplayer on one machine and turned it into multiplayer on two machines. So let's go ahead and walk through the different parts. So it's divided into PAs, PA 5 being to recreate this game as data-driven, PA 6 to be to add a lobby so that two machines can connect, and then PA 7 is to actually pass that information over the network and both sides to properly organize themselves according to that information, and then PA 8 is to add artificial issues on the network and then make each machine compensate accordingly. So I'm going to go ahead, and this is part of PA 6, go ahead and log into my local system account. And then here I have three options. I can either press A to host, B to join a session that's already existing, or escape to exit out of the game. So I'm going to go ahead and host, and then on the secondary machine I'm going to go ahead and start searching for this hosted game. As soon as the player 2 finds me, then the game automatically gets started. Everything is zeroed out. Player 1 is the blue guy, and I have left, right, up arrow to move the ship, spacebar to fire a missile, and M to drop a mine. The other player has the exact same controls, except they control the green guy, player 2. So, as I am pressing up, down, left, right, fire, what's actually happening is the information is being encapsulated into a packet, which is then sent to actually request the command on the local machine. That's the data-driven part. That's PA 5. PA 7, which is actually putting that information over the network. So these packages are actually being sent over the network, and on both machines simultaneously are actually the location updates are being sent to the main machine. Then the input is being sent to the main machine. Then the actual location updates, which is where the objects are located, is being broadcasted to both the client and the host. And those are also being sent through packets. This way, all the requests are being sent to one machine and updating locations on one machine. Then both machines are actually displaying what the host is thinking where everything is located. This plays well with the third part, which is thrown into the data-driven, which is collision detection. Collision detection happens only on the host machine, and when it's detected, the two items that are colliding and the location is being sent back, sent to the host as well as to the client machine through the packets. So that's essentially, in summary, for PA 5, what's being sent is requests to move one or the other ship. Host sends ship 1, the client sends ship 2, then everything else is being sent from the host only. That is updates of the location of the object, like I said, that's updates to collisions. So when it was split off in PA 7 to separate networks, then each machine does exactly that. One becomes a host, the other one becomes a client. The host sends location updates as well as requests to move the ship, rotate it. Both machines send in their input for the respective ship. The request essentially saying, hey, can you move my ship this way, turn it that way. And then the host machine acknowledges and actually does that. To be able to find the objects on both machines for collisions as well as location updates, I've created a unique ID system where each item can be found by its unique ID, looked up on both the host and the client machine because they are synchronized, and then it will essentially do that and find the local object and update it respectively. Let's go ahead and quickly take a look at PA 8. In here, what happens is the display will show you several options. You can control packet loss, you can control network simulation, where it simulates, like I said, packet loss, and then how often packets are sent from the host network. And then I can turn on prediction and smoothing. Prediction I set up to actually take where it currently is, where it was last time, and predict where the next spot is and move the item to that location every cycle. whether there's a packet drop or not. Smoothing instead takes where the current request is to put the object. Instead of putting it directly there, it holds it temporarily for itself and always moves the object only a third of the way to the current assumed location. This gives a smooth effect, but it's always trailing behind. So let's go ahead and enable packet. Let's go ahead and enable packet loss. So let's see here. So right now, as you can see, everything is moving smoothly. And now tab shows everything. Then everything is respectively Q, W, E, R down the line. So now you can see I've turned on full packet loss. That means every 12 set of packets is lost for the ships. So I'm only finding updates every so often. It's very jerky. If I turn on smoothing, which is R, then as you can see, immediately I see progress, but there's still a hint of lagging behind. It feels like it's being pulled. If I turn that off, it's back to normal, where it's jumping every frame. If I turn on prediction, immediate super smoothness, because it's automatically finding, okay, it went from there to there. I know, okay, I need to move it this part, keep moving it forward in that direction. Now if I turn on both of them, I feel like you get the cream of the crop. First off, it's super smooth. I can't tell that there's a packet loss. And secondly, when I'm turning, I feel I have a little bit more control because there's a slight slowness to the control. Now watch, if I turn everything off, and as well as packets, then watch, you see how my turning is a lot faster, and also my ship is kind of spinning around that point. But if I turn super high packet loss and turn both of these things on, when I'm turning, I'm no longer turning around that point, I'm more turning around the side of the ship almost. Unless I hold it for a super long time. So definitely prediction and smoothing works. That concludes my demo of making this game data driven. Adding the lobby, and then also, let's go ahead and turn those visuals off. Passing the information over the network. The final thing I want to show you before I conclude is if I press escape, actually before I do that, let's go ahead and kill that last ship. You see, it just reset the game, and I got one win, and everybody gets their lives back. I can always go back here, exit, and then I can host again. The other machine is going to join. And voila, everything's been completely reset. No more kills, no more wins. I can do this as many times as I want. I can even host on the other machine, and I can join on this machine, and it'll always reset it to a new game, and both machines will be able to play again. Now, since I am the client, watch, my controls move the green guy. And the other machine, the host machine, which is now the other computer, is controlling number 2. So that concludes my demo. I hope you enjoyed it.